Alright, so in this video, we're going to solve more trigonometric equations. So this is probably the third video, or part 3 of this topic. And these questions are actually under trigonometric identities. So we're going to be solving equations, but we're going to have to use some identities in order to be able to solve them. So, alright, so A and B are quite similar in question types. So I'm going to solve A, and I'm going to leave B to you. So A says 2 sine squared theta and 2 sine squared x plus sine x minus 1 equals to 0. Alright, and it's always very helpful to remember that sine x is bounded by -1 and +1. Alright, so this is the bound that you need to remember. And we are going to substitute sine x to be u. After we do the substitution, we can write this equation as 2u squared plus u minus 1 is equal to 0. Why do we do this? Well, this makes things easier to factorize. This is a quadratic equation, and we know how to solve quadratic equations. So you can use the formula, you can try to factorize this, whichever is easier. So when I look at this, I see that my sum is 1, and my product is equal to -2. And my two numbers can be 2 and -1, right? If you add these two together, 2 and -1, the sum is 1, and the product is -2. All right. So now I can write this as 2u squared plus 2u minus 1 is equal to 0. And from this, I can factor out a 2u from the first two terms. So this is using the factorization method that we already discussed. So I get u plus 1. I factor out a -1, and I get a u plus 1 here. And now when I rearrange everything, or when I factorize out u plus 1, I get u plus 1 times 2u minus 1 is equal to 0. So therefore, I have two solutions. U is equal to -1 from my first term, right? I can set u plus 1 is equal to 0, right? Which gives u to be -1. And from this term, I know 2u minus 1 is equal to 0. So 2u is equal to 1, and u is equal to 1 over 2. All right, so u is just sine of x equals to -1. And now let's look at the graph of sine of x in this domain from 0 to 360, right? So the graph of sine of x looks something like this. It goes up to +1, it comes down to 0, it goes down to -1, and it goes back up to 0, right? So sine of 360 degree is 0, sine of 180 degree is 0, and sine of 0 degree is 0. Sine of 90 degree is +1, and sine of 270 degree is -1, right? All right. So now that we know this, we know that x is 270 degrees. Sine of 270 degrees is -1. So if you actually do sine inverse of -1, you're going to get -90 degrees, right? So -90 degrees, and you're going to have to use that. So it's easier if you just know your graph. If you know the graph of sine of x, you know that sine of 270 degrees gives you -1, given that 270 degrees is the angle as specified by the domain, right? And u is half. All right, so half is somewhere over here. So you can see that it's going to cut exactly twice between 0 and 360, right? And this is something we've done before. This is from the previous two videos. You probably have an idea on how to go on about this. So now I can do x is equal to sine inverse of half, or I directly know because I know that sine of 30 degrees is half, right? This is from a standard angle. So x is equal to 30 degrees. And I know that my second quadrant answer, right? If I have an acute angle and sine is positive in the first and the second quadrant, I can get my second quadrant answer by just subtracting 30 from 180. So that gives me 150 degrees. So my three solutions are 270 degrees, 30 degrees, and 150 degrees. All right. So those are my three solutions, 30, 150, and 270. Okay, and we are done with question 1. In question 2, you can solve it in exactly the same way. All right. Let's solve question B, part B. You can set tan x to be u, and yeah, go on about it like that. All right. C. We have 3 cos squared x minus 2 sine of x minus 1 equals to 0. So we have two different variables. We have cos x here, which is squared, and we have sin x here. And it's more easy for us to work with, or it's easier for us to work with one variable. So I know that I can write cos squared x as 1 minus sin squared x. Right? And this is from the identity. Sin squared x plus cos squared x is equal to 1. So if you use that identity, you can see that cos squared x is actually 1 minus sin squared x. And I get this. And this can be simplified. And if you rewrite this, it looks something like minus 3 sine squared x minus 2 sine of x plus 2 equals to 0. And if you just multiply through by negative 1, because I like my first term being positive, I get something like this. So my two negative terms, if I multiply by negative 1 on this side, my left-hand side looks something like this, and my right-hand side multiplied by negative 1 is still the same. All right, and now I can just say sine of x is equal to u. So 3u squared plus 2u minus 2 is equal to 0. So now let's try to factorize this. We have a product of negative 6, and we have a sum. 3 times negative 2 is 6, negative 6, and a sum of 2. So what two numbers could this be? Let's think about it. I don't think this is possible, right? I don't think there is a easy answer for this. So let's use the quadratic formula. All right, maybe there is, and I didn't think enough about it. But the quadratic formula says that u is going to be minus b, so minus 2, plus or minus the square root of b squared. 2 squared is 4, minus 4. And I hope you're comfortable with me using the formula because we've already discussed this in our previous videos. A is positive 3 and C is negative 2. All right, divided by 2A. 2 times 3 is 6. All right, so minus 2 plus or minus. If you simplify, and I'm going to do it very quickly, but you get 4 minus, you get something like this, right? 4 3s are 12, 2 times negative 2 is negative 24, and 4 plus 24 is actually 28, I think. So if you simplify the term inside the square root, you get something like this. All right, so minus 2, 4 minus 4 times 3 times negative 2 is 28, all right, divided by 6. And you can simplify it further, but let's think about it, right? So, square root of 28, right? Square root of 28 is 5. So, square root of 28 is approximately 5.29, right? So, you take the negative value. So, usually when you solve for the roots, right, you have two values. You have minus 2 plus square root of 28 divided by 6, and you have minus 2 minus square root of 28 divided by 6. So let's think about the minus part. Minus 2 minus square root of 28, right? So that is minus 2 minus 5.29. So that is about negative 7.29, right? So negatives we have, so that is approximately, so one solution is negative 7.29 divided by 6. And this negative 7.29 is less than negative 7.29 divided by 6 is less than negative 1, right? And if you remember, sine of x has to be bigger than or equal to negative 1 and less than or equal to positive 1. So keeping this in mind, you can see that the negative solution here is invalid. So you only have to worry about the positive solution because u, remember, is sine of x. All right. So using that knowledge, sine of x is just going to be minus 2 plus square root of 28 divided by 6. You don't have to worry about the minus square root of 28 part. Why? Because this expression, if you use minus square root of 28, is less than negative 1. And sine of x always has to be bigger than or equal to negative 1 and less than or equal to positive 1. All right. So you can keep this expression as it is. You can simplify, you can use your calculator to simplify it down, whichever you prefer. All right. So now So minus 2 plus square root of 28 divided by 6 is, so this is, if you use your calculator to estimate this, is about 0.5485837704. All right, so now let's find x by taking the sign, because this is a positive value. So I'm going to get my answer in the first quadrant, right? Based on previous knowledge from previous videos. So 54 dot dot dot. So I'm going to just take the sine inverse of the answer. And okay, sorry, my calculator was in radians. So let me just change it quickly to degrees, because in this question, we're working with degrees here. So, all right, sine inverse of 0.548583 yada yada. This is 33.3 degrees to 1 decimal place, approximately. And if I get the acute angle, I know my other solution. I just subtract my acute angle so that I send sine into the second quadrant where it's also positive. All right, so I get 180 minus my previous answer, and I get 146.7 degrees. All right, so these are my two solutions, 33.3 and 146.7 degrees. All right, so we are done with question C. Okay, let's look at part D, because part D looks interesting as well, and I'm going to leave part E to you. So, all right, so let's continue with part D. So part D, we have 3 cosecant squared x is equal to 13 minus cot x. Again, we have two different variables. We have cosecant x, we have cot x. So let's simplify it into one variable. All right. So how do we do that? Well, to do that, we must remember that cot squared x plus 1 is equal to cosecant squared x. All right. And now that we know that, we can just substitute this expression here. This is just cot squared x plus 1 is equal to 13 minus cot x. All right. So now if we simplify this, we get this expression. And now we can simplify this further. We can write this as 3 cot squared x plus cot x. If I bring this here, and I'm going to bring 13 here as well, right? I'm bringing everything from the right-hand side to my left-hand side. So if you do that, you get this expression. All right. And I'm going to leave you to figure out how we get to this expression. And we can continue working on. So let's rename cot x to be u. Now, usually we try to work with sine, cos, and tan, but you'll see how that working like this is also fine. But we're going to switch things up towards the end. So we have 3 u squared plus u minus 10 is equal to 0, right? And now let's try to factorize this. I think it's a bit difficult. So we have our product is going to be negative 30, right? Negative 10 times 3. And our sum is going to be positive 1, right? From our middle term. So the two numbers that are going to satisfy these are 6 and negative 5. That's kind of hard to see, but I hope you see it, right? 6 times plus minus 5 gives you positive 1. And if you multiply them together, you get negative 30. So you have 3u squared plus 6u minus 5u minus 10 is equal to 0. From the first two terms, you can factor out the 3u, and you get u plus 2. And from the second two terms, you can factor out the negative 5, and you get u plus 2 as well. And you can write this as u plus 2 times 3u minus 5 equals to 0. All right. And now, the first possibility is that u plus 2 equals to 0, which means u is equal to negative 2. And cot x is equal to negative 2. That is one possibility. But we're not comfortable with working with cot x. So we need to write this as 1 over tan of x is equal to negative 2. And this becomes very quickly into this expression, right? And this is something that we know how to solve. So we just get the acute angle. So the acute angle, you just take tan inverse, you ignore the negative sign here, and if you've watched the previous video, you sort of know what I'm talking about. You can just take tan inverse of 1 over 2, and you get your acute angle between 0 and 90 degrees. So you take tan inverse of 0.5, you get 26.5650518 degrees, right? And now you want to send this acute angle into the quadrants where tan is negative. Where tan is negative, because we are solving for this, remember? So when is tan negative? Tan is negative in the second quadrant. So your first solution is going to be 180 minus your acute angle. And you get, so your first solution is 153.4 degrees. And tan is negative in the fourth quadrant as well. So to get your fourth quadrant solution, you just subtract your acute angle from 360. All right. And you get 333.4 degrees. And yeah, we are done. So we are done with solving one part. Now we need to go back and solve for this part. 3u minus 5 is equal to 0. 3u is 5, right? 3u is cot x is equal to 5, right? And 3 over tan x is going to be 5. And if you isolate tan x, you are going to get tan x is equal to 3 over 5, which is 0.6. All right, and now if you solve this, x is tan inverse. So if it's positive, you can just directly take tan inverse, and that acts as one of your solution because you get an acute angle. So you get 30.96 degrees, right? You can simplify it to 31.0 degrees as well if you want. And to get your other positive solution, you need to go to the third quadrant. So your other solution is going to be 180 degrees plus your acute angle, right? To go to the third quadrant. So you get 210.96 degrees. All right, so we are done. And we have our 4 solutions. So that is how you solve part D. And let me quickly check. Part D, 30.96, 210.96, 153.4, and 333.4 degrees. All right. So let me quickly erase it, and I'll leave E for you to try on your own. And we need to go to part F. All right. Part F is square root of 3 secant squared x is equal to cosecant x. Now I have secant and I have cosecant. I'm not really comfortable with this, so let me just change it to sine and cos. So I can write this as secant squared x is just 1 over cos squared x. Cosecant squared x is 1 over sine of x. All right. So I've gotten to this point. And now I can multiply by both sides by cos squared x, right? I'm going to multiply both sides by cos squared x by cos squared x. And these will cancel out. So I get root 3. And on my left-hand side, I get cos squared x over sine of x, right? Now I can simplify this further because cos squared x is just 1 minus sine squared x over sine of x, right? And I can multiply both sides by sine of x, and I get this expression, root 3 sine of x is equal to 1 minus sine squared of x. And if you simplify this, you know that sine squared of x plus root 3 sine of x minus 1 is equal to 0. If I bring everything on my left-hand side to my right-hand side. Now this is harder to factorize, so we're just going to use the quadratic formula. So if I say sine of x is equal to u, then I have u squared plus root 3u minus 1 is equal to 0. And I'm going to directly use the quadratic formula. So if you use the quadratic formula, u is going to be minus b plus or minus the square root of b squared. So root 3 squared is 3 minus 4, a is 1, c is negative 1, right? So overall, you're going to get plus 4 here. And this expression inside your square root is going to simplify to 7 divided by 2. All right, so now let's check. Negative root 3, let's check the negative side, right? Minus root 7 divided by 2. So if you look at the negative solution, minus root 3 minus root 7 divided by 2, that is negative 2.1889 something, right? And this is much less than negative 1. And you know that sine of x is between negative 1 and positive 1. So that means that the negative solution is invalid. So you just need to check for u plus square root of 7 divided by 2. This is going to be the only valid part of your solution. All right. So if you want to solve, if you use your calculator, negative square root of 3 plus square root of 7 divided by 2, you are solving for u is equal to 0.4568502517. So this is just sine of x, is this expression, right? So because it's positive, you can find your acute angle by just taking the inverse. Dot, 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 dot. So sine inverse of this value is just 27.2 degrees. And how do you get your second quadrant solution? Well, to get your second quadrant solution, you just subtract it from 180. And you get 152.8 degrees. So those are your two solutions. All right. So 27.2 degrees and 152.8 degrees. So that's how you solve part F. I know it was a bit convoluted, but I hope the explanation is clear. All right. Moving on. Let's do part G. I'll leave for you to try on your own because it requires substituting. It requires you to use the identity. So it's very similar to D, actually. So, okay, I'll do E then. I'll leave G for you to try because it's very similar to D. So I'll do E. So I left... So B is something I haven't done. I'll leave G to you. D I did. I believe I did C as well. And I did F. All right. And because I've done C, H is very similar. So I'm going to leave... you can go back and watch how I solve part C and try to solve part H on your own. Let's see if there's anything that's similar. So I is also very similar to G as well. So I'll leave that for you to try on your own. So I'll do J and E. All right. So E says that cosecant x plus cot x is equal to 2 sine of x. So this is actually fairly simple. Cosecant x is 1 over sine of x. Cot x is cos x over sine of x is equal to 2 sine of x. All right. And now if you simplify this, you get 1 plus cos x divided by sine of x is equal to 2 sine of x. And I'm going to multiply sine of x to the other side. So I have 1 plus cos x is equal to 2 sine squared of x. And sine squared of x, I can write it as 1 minus cos squared of x using the identity. And why? Because I have cos x as my variable here. So the overall expression, I can write it like this. So 2 cos squared of x. Right. So because I want to write it as one variable, so I bring everything to one side, right? I have 2 cos squared x plus cos of x, and 1 minus 2 is going to give me negative 1. And this is something that I believe you can factorize. So if you use the sum and product method, the sum is going to be positive 1, the product is going to be negative 2, and the two factors are going to be 2 and minus 1. So you have 2 cos squared of x plus 2 cos of x minus cos of x. So instead of substituting, I'm solving it directly. So from these two terms, I can factor out 2 cos of x, right? Previously, I was saying that u is equal to cos of x and then solving, but you can do it directly as well. That's not an issue. And inside the bracket, I'm going to have cos of x. Remember, cos of x times cos of x is going to give me the first term plus 1, right? And if I factor out in negative 1, I get the same term on the other side. So now I can factor out cos x plus 1. And I have 2 cos x minus 1. Now I can solve for cos x plus 1 is equal to 0, which means cos x is negative 1. And if you know the graph of cos of x between 0 and 360 degrees, then you know that the only angle that satisfies this is 180 degrees. Cos of 180 degrees is negative 1. Cos 0 is positive 1. Cos 90 is 0. Cos 180 is negative 1. All right, so cos 270 is 0 again, and then cos 360 is back to positive 1. So we only have one solution from this. And from this, I know that 2 cos of x is 1. right? I send 1 to the other side when I solve, or I can write this equal to 0, 2 cos of x is equal to 1, cos of x is equal to 1 over 2. Now x, if you remember your special angles, 60 degrees, cos 60 is half, and between 0 and 360 degrees, cos is positive in the first quadrant and the fourth quadrant. Now, how do we get our fourth quadrant solution? Well, you just do 360 minus your acute angle. So 300 degrees is also going to be a solution. And remember, you're finding solutions within this domain. That is why I can subtract from 360. That is why I can add to 180, because I'm working here. If I was working at another domain, I would have to be thinking in a different way. All right. So this chapter requires you to think a lot, especially about the domains. So yeah, your three solutions are 180, 60, and 300. For part, I believe it was E that I was doing. And the textbook only lists 2 solutions. I'm not particularly sure why. Okay. So this solution is going to be invalid, actually. This is an invalid solution. And the reason why this is invalid is because we forgot something here. I have 1 over sine x. I have this expression here. This is the expression that we started with. We must obey this expression, right? So this has the condition that sine of x does not equal to 0. That means x does not equal to 0 degrees, 180 degrees, and 360 degrees. So because of this condition, we have to reject this 180. And we only have 2 solutions, which is 60 degrees and 300 degrees. All right. Originally, I planned to do part J, but then if you try to solve part J, it gets very convoluted, it gets very difficult very quickly. And another thing is that the solutions that the textbook lists does not actually satisfy this. The solutions do not actually satisfy this equation. So probably it's a misprint. So maybe the question was different, and here it's printed different. So I'm gonna skip this part J for now. So we're gonna go ahead, and I think you can skip part J as well, because the solutions that should be correct don't match. The textbook solutions given don't actually match this equation. If you substitute them in, you're gonna get different values. So probably the question is a misprint. Maybe they wanted us to do things differently. I'm not really sure, but the textbook solutions don't really satisfy this equation. You can try to plug them in. The textbook lists 30 degrees, 150 degrees, 270 degrees. Now, 270 degrees does look like a valid solution, but the problem is tan of x is not defined at 270 degrees, right? Tan of x is asymptotic at 270 degrees. So because of that, there is a domain issue for this question as well. It's a bit ambiguous. So we're going to skip J for now. And possibly if there's a bit more clarity in the future, I'm going to come back and solve it for you. All right, solve each of these equations for this domain restriction. So we're going to go straight ahead to 2a. Tan of x is sine of x over cos of x is equal to 3 cos of x. All right, now we need to note one thing. Cos of x is in the denominator. So cos of x cannot be equal to 0. So x cannot be equal to 90 degrees, and it cannot be equal to 270 degrees, right? But 270 degrees is out of the domain anyways, so we're just going to consider 90 degrees. All right, so now I can multiply both sides by cos x. So I get 3 cos squared x, and cos squared x can be written as 1 minus sine squared x. All right, so I can write this as 4 sine of x is equal to 3 minus 3 sine squared x. And if you bring your right-hand side to your left-hand side, you get the equation 3 sine squared x plus 4 sine x minus 3 is equal to 0. And let's try to factorize this. So my sum is going to be 4. My product is going to be 9. Negative 9, right? To think of 2 numbers that satisfy this is quite difficult. So basically, let's say sine x is equal to u. So you have 3u squared plus 4u minus 3 is equal to 0. We have this equation. So u is going to be minus 4 plus or minus the square root of 4 squared, which is 16, minus 4, a is 3, c is negative 3. Right, so we have 16 minus 4 times 3 times negative 3. So your inside is going to simplify to 52 divided by 2a, so 6. All right, so now if you think about it, minus 4 minus square root of 52 divided by 6. If you look at the negative solution, right, minus 4 minus square root of 52 divided by 6, that is negative 1.86. And remember, your sine of x, which is what we're working with, has to be bigger than or equal to negative 1. So the only solution that we have to worry about is the positive solution. All right, so if you put this in your calculator, you get 0.5351837585. So sine of x is equal to this ugly value. And because it's positive, we can directly take sine inverse to get our acute angle. Right? If it's negative, we have to adjust a bit, but we can do it directly. So you get 32.4 degrees as one solution. And sine of x is positive in the second quadrant as well. So to get your other solution, you subtract your acute angle from 180 because you have to send it to the second quadrant, and you get 147.6 degrees. All right, so these are your two solutions for 2a. So if you check your textbook again, so this is given in degrees. Your textbook lists the solutions in radians. I don't know why. I have no idea why. So these are your two solutions. Maybe if you try to convert them to radians. So 320. But I don't know why the textbook lists the solutions in radians. Maybe we can try to convert. So we know that 360 degrees is equal to 2 pi radians. So 1 degree is 2 pi divided by 360. And I need to multiply by 32.4, right? To get to 32.4 degrees into radians. So it would be something like 2 pi divided by 360 times 32.4, 0.56. Okay, so 0.57 radians. So it matches. Right? And for your other solution, you need to do the same. 2 pi by 360 times 147.6 radians. So you get 2.57. So because your domain is in degrees, I would prefer to list it in degrees, but your textbook gives it in radians for I don't know what reason. So you can just convert your final answer back to radians. All right. So I'm going to leave part B to you because we've done similar questions, right? This, instead of cosine squared x, you just substitute 1 minus sine squared x. And everything else is routine, right? So let's do C. Tan squared x plus 3 secant of x plus 3 is equal to 0, right? So tan squared x is just, remember, we have this identity, tan squared x plus 1 is equal to secant squared x. So tan squared x is just secant squared x minus 1 plus 3 secant x plus 3. And we can simplify this. This becomes secant squared x plus 3 secant x plus 2. Minus 1 plus 3 gives you positive 2. And now let's try to factorize this. Two numbers with the sum of 3. The product has to be 2, and then your two numbers are going to be 2 and 1, right? So we get this expression. Secant squared x plus 2 secant x plus secant x plus 2. All right, so if you factor out the secant x, we can get secant x plus 2, and then if you factor out the 1 here, you get the same. So the factorization here is going to be secant x plus 1. So you can substitute u and do this as well. That is not an issue. you get this factorization. All right. So now you can solve secant x plus 1 is equal to 0. Secant x is equal to negative 1. 1 over cosine of x is equal to negative 1. If you rearrange, you get negative 1 is equal to cosine of x. Did we have any restrictions here? Not really, right? So when is cosine of x negative 1? Well, cosine of 180 degrees is negative 1. So that is one solution. Let's try to solve this. Secant x is equal to negative 2, right? If you set this equal to 0, so 1 over cosine of x is equal to negative 2, and cosine of x is negative 1 by 2. All right. So x is going to be negative half. So what is the acute angle that gives me positive half? Well, the acute angle is 60 degrees. And cosine is negative if you look at the domain, right? You can solve it in another way as well. But I only have my first two quadrants, and cosine is negative in the second quadrant. So I just need to do 180 degrees minus 60 degrees. And cosine 120 is going to be negative half. So your two solutions are 180 degrees and 120 degrees for part C. So this is pi has to be a solution. Let's see, are we missing any solutions? 120 degree is 2 pi by 3. And so your textbook lists 4 pi by 3. If you remember, pi by 3 is 60 degrees, right? In radians. 4 pi by 3 is going to be 4 times 60 degrees. So that's 240 degrees. And 240 degrees is outside of this domain restriction. So your three solutions, you only have two solutions, which is pi and 2 pi by 3, which is your textbook lists. And 4 pi by 3 is going to be out of the domain, in my opinion. So that is how you do C. All right. Let's look at D. So we have 3 cot squared x plus 5 cosecant x plus 1 is equal to 0. And rather than working, we can use the identity, right? Cot squared x is just cosecant squared x minus 1. And I'm going to leave you to figure out how I get to that point. So we have 5 cosecant x plus 1 equals to 0. And now, if I simplify, and I'm going to leave the simplification to you as well, I get 3 cosecant squared x plus 5 cosecant x minus 2 equals to 0. Let's see if we can factorize this. And I think we can, because the product is negative 6. 3 times negative 2. The sum is 5. So the two numbers have to be 6 and negative 1, right? That gives me a product of negative 6, a sum of 5. All right. So 3 cosecant squared x plus 6 cosecant x minus cosecant x minus 2 equals to 0. If you factor out 3 cosecant x from my first two terms, so you could have substituted cosecant x is equal to u and done this as well. But I get cosecant x plus 2 minus 1. You factor out the negative 1, you get cosecant x plus 2. All right. So here we have this expression. All right. Cosecant x plus 2 is equal to 0. Cosecant x is equal to negative 2, right? 1 over sine x is equal to negative 2. Sine of x is equal to negative 1 by 2. So now let's solve for this, right? Between 0 and 180 degrees. So x, there is no solution, right? Why? Because 0 and 180 degrees, we're in the first and the second quadrant, and sine is always positive. So there is no solution for this expression. All right, so let's work with this. 3 cosecant x is equal to 1. Cosecant x is equal to 1 over 3. 1 over sine x is equal to 1 over 3. And sine of x is equal to 3. But this also has no solution. So this inequality, this equation for 2D should have no solution. If you check the textbook, they give you 7 pi over 6 and 11 pi over 6. So pi over 6 is 30 degrees, right? 11 times 30 degrees is 330 degrees. So this is beyond 180 degrees, right? And 7 times 30 degrees is equal to 210 degrees. So this is also beyond 180 degrees. So given the domain restriction, D has no solution. If you check your textbook answer, they give you angles, but these angles are bigger than 180. So I've seen that some of the answers here are very inconsistent in the textbook. So please follow your teacher. Yeah. All right. So we have question C and question D. All right, question 3. So let's go through question 3. So with 3e says secant theta is equal to 3 cosine of theta minus tan theta. All right, so again, this is the domain restriction. Secant theta is just 1 over cos theta. I can write this as 3 cos theta minus this is just sine theta over cos theta. But cos theta is in the denominator. So cos theta cannot be equal to 0. And theta does not equal to 90 degrees, right? Cos 90 is 0, so it cannot be 90 degrees because 90 degrees is the angle within that domain, right? So it cannot be equal to 90 degrees. All right, so let me multiply through by cosine of theta. And I get 3 cosine of theta. So I multiply both sides by cosine of theta, or I just multiply this on the other side, and I get this expression. And I can write this as 1 minus sine squared theta minus sine theta, and this simplifies to 3 minus 3 sine squared theta minus sine theta, right? And I can take everything here. So I get 3 sine squared theta plus sine theta minus 2 is equal to 0. And this is something I think I can factorize, right? So if you use the factorization method, you're going to see that you're going to get 3 and negative 2 are going to be your factors. So 3 sine squared x, 2 numbers, right? Plus 3 sine theta minus 2 sine theta minus 2 is equal to 0. And I factor out 3 sine theta. And I get sine theta plus 1 minus 2. And I also get sine theta plus 1 again. So I get this expression. Now, sine theta plus 1 and 3 sine theta minus 2. So this is something that I get, right? So this is just something that we have done even in the previous videos. So now, first step, I solve for sine theta is equal to negative 1. If I set this part equal to 0. Setting this part equal to 0, I get this. And between, this has no solutions. Why? Because between 0 and 180 degrees, sine is never negative, right? So this one has no. And this one tells me that 3 sine theta minus 2 is equal to 0. So sine theta is equal to 2 over 3. And because this is a positive value, I can get an acute angle by taking the sine inverse. All right. So sine inverse of 2 over 3, that gives me 41.8 degrees. And to get your other angle, it's going to be in the second quadrant because sine is positive in the second quadrant. So I get 180 minus 41.8. So I get 138.2 degrees, right? So it's basically what we have been doing so far. So my two solutions are 41.8 degrees and 138.2 degrees. All right. So that is how you solve A. And remember, it cannot be 90 degrees. 41.8 degrees and 138.2 degrees. I hope it's clear. All right. Part B. We have 2 secant squared 2 theta is equal to 3 tan 2 theta plus 1. Remember, 0 theta. So we have this inequality. So let's look at this inequality in perspective of 2 theta, right? And 2 theta can be between 0 and 360 degrees. All right. So now I'm going to call 2 theta to be s. So I can rewrite this equation as 3 secant squared, let me pick something else like t. All right, so 3 secant squared t is equal to 3 tan t plus 1. Secant squared t, if you remember, in a tan squared t plus 1 is equal to secant squared t, right? So now secant squared tan, if you want your expression of secant squared t, then that's just tan squared t plus 1. All right, and that is going to be 3 tan t plus 1. Then if you simplify everything, you get 2 tan squared t plus 2 is equal to 3 tan t plus 1. All right. So if you simplify everything, you get this. And let me bring this here. So 2 tan squared t minus 3 tan t plus 1 is equal to 0. So now let's think about this. Can we factorize this? I think we can. So if you factorize this, if you look for your two numbers using your sum and product, you're going to get minus 2 and minus 1. Why? Product is positive 2 and the sum is negative 3. All right, so minus 2 tan t minus tan t plus 1 is going to be 0. So I'm going to try to factorize this. So I can factor out to 2 tan t from my first two terms, and I get tan t minus 1. And from my second two terms, I can factor out in negative 1. And that gives me tan t minus 1. And if you remember the videos from solving quadratic equations, you are probably familiar with this. So my two factors are going to be tan t minus 1 and 2 tan t minus 1. All right, so now let's solve for tan t is equal to 0. And between 0 and 360, right? T is between 0 and 360. So we can easily solve for this. Tan t is equal to 1 if you solve using this one, right? So now we know that t can be 45 degrees because tan 45 is 1, and t can be 180 degrees plus 45 degrees. 180 plus your acute angle sends you into the third quadrant, and tan is positive in the third quadrant. So that is 225 degrees, right? So t is 45 and t is 225 degrees. So, but remember, t is just 2 theta. So this implies that theta is 45 by 2 is 22.5 degrees. And 2 theta is also 225 degrees. So that implies that theta is going to be 112.5 degrees. All right. So we have two of our solutions. Now we need to solve for this one. 2 tan t minus 1 is equal to 0. So if you simplify, you get tan t is equal to 1 over 2. So for the acute angle, you can just do tan inverse of half, and that gives you 26.56 something degrees. Just keep the value in your calculator. And remember, your other solution, tan is positive in the third quadrant, so you can just add this to 180. So you get 206.56 degrees. Now you need to solve for theta, right? So this just means that 2 theta is equal to 26.56 degrees, and you're going to solve for theta, which is going to be 13.3 degrees. And if you solve this for theta, you're going to get 103.3 degrees. All right, so we have our four solutions: 22.5, 112.5, 13.3, and 103.3 degrees. All right. So that we are done with part B. Let's do part C. Part C is this expression. Secant 4 theta plus 2 is 6 tan squared theta. All right. So I know that, hey, this expression here, I can write it as secant squared theta squared plus 2 is equal to 6 tan squared theta. And secant squared theta is just 1 plus tan squared theta. All right, now let's simplify. If you expand, you get 1 plus 2 tan squared theta plus tan to the power 4 theta plus 2 is equal to 6 tan squared theta. All right, so now we need to simplify further, and if you bring this to your left-hand side, we are going to get the expression tan to the power 4 theta minus 4 tan squared theta plus 3 is equal to 0. And let's say that tan squared theta is equal to u. So we have u squared minus 4u. This is something that we have done before, right? When we had something to the degree 4, we just said, okay, I can call this term to be tan squared theta squared, right? So I have u squared minus 4u plus 3 is equal to 0. Let's try to factorize this. I believe we are going to get minus 3 and minus 1, right? If you expand this, you will get this expression back. So u can be 3 and u can be 1. Remember, u is just tan squared theta. And here u is just tan squared theta as well. So let's solve for this first. If tan can be plus or minus 1, right, from this case. So when is tan positive 1? 45 degrees gives me positive 1. And because theta is between 0 and 180, I can get tan is going to be negative 1. So tan of positive 1 is going to occur in 45 degrees. There is no second quadrant solution because tan is negative there. Now tan theta is negative 1. If I need to solve this one, then it's going to be the second quadrant solution. So to send theta into the second quadrant, I can subtract 180 minus my acute angle. And you can solve it in any way that you like, with referencing to the previous video. But if I know my acute angle that gives me the positive of the right hand side, then I just need to send that acute angle into the right quadrant. So in the second quadrant, tan is negative. So I just do 180 minus 45. I get 135 degrees. So I have two solutions, 45 and 135 degrees. All right. So now we're looking for two more solutions, right? Should be 45 degrees, not 45.3 degrees. From this, I get tan theta is equal to plus or minus square root of 3. So again, if I solve for tan theta is positive square root of 3, I know that theta is just 60 degrees directly, right? I don't need to worry. And there is no second quadrant solution to this one because second quadrant tan is negative. All right, so you solve for tan theta is this expression, then you know that you just need to subtract your acute angle from 180 to send it to the second quadrant, and you get 120 degrees. So we have our solution, 60, 120, 45, 135. All right. So we are done with C. And finally, we have to do D. And it's the same procedure, right? It's the same procedure. So we know that, hey, 2 theta, which we will call T, is going to be between 360 degrees and 0 degrees. We know this from question part A, right? Part B. When we saw part B, we did the same thing. So now I know that, hey, I have 2 cot squared T plus 7 cosecant T is equal to 2. All right. So I can write this one as 2 cos squared T over sine squared T plus 7 over sine T is equal to 2. Now if I multiply both sides by sine squared T, and remember, sine T is in the denominator. So sine T cannot be equal to 0. T cannot be equal to 0, 180 degrees, and 360 degrees, right? For this restriction. So because T is 2 theta, I can get that theta cannot be equal to 0, 90, and 180 degrees. So I just need to divide by 2 on both sides of this expression. All right. So now I get 2 cos squared T plus 7 sine of T, right? If you multiply through in this side, I get 2 sine squared T here. All right. Now cos squared T, I can just write it as 1 minus sine squared T plus 7 sine T is equal to 2 sine squared T. So now I'm going to send everything to the left-hand side. To the right-hand side. Why? Because I want the coefficient of sine squared T to be positive. So if you bring everything to the left-hand side, you're going to see that the coefficient is negative. I want it to be positive, so I'm going to send everything to the right-hand side. All right, so I get, if you simplify everything, you get 4 sine squared t minus 7 sine t minus 2 is equal to 0. That is what you're going to get. All right, so now, can we factorize this? I think we can, right? Or we probably cannot. Let me think about it. I think we can. So if the two numbers are going to be negative 8 and positive 1. All right, so we have 4 sine squared t minus 8 sine t plus sine t minus 2. So if you try to factorize this, you're going to get an expression like this. And you can factor out 4 sine t, and you get sine t minus 2. And if you factor out a positive 1, you get sine t minus 2 equal to 0. And you know that sine t minus 2 and 4 sine t plus 1 is equal to 0. Now let's solve for this. Sine t minus 2 is equal to 0. Sine t is equal to 2. But remember, sine of any angle is between positive 1 and negative 1. So this is not possible. So we just need to focus on this. 4 sine t plus 1 is equal to 0. 4 sine t is going to be negative 1. And sine of t is going to be negative 1 by 4. And we're solving for 0 to 360, right? So I know that sine of... So if you just do sine inverse of positive 1 by 4, which is 0.25, I get... So you can just take sine inverse of the positive value, which is 14.4775 ... degrees. So I know that sine of 14.4775 ... degrees gives me positive 0.25, right? Sine of this angle gives me this value. But this is an acute angle. It gives me the value that I need, but I need the value to be negative. So I just need to send this acute angle to the right quadrant, which is going to be the third quadrant because I'm working with t, remember? So t can be between 0 and 160. So I need to send it to the third quadrant. To do so, I'm going to add 14.4775 ... degree to 180. So that is going to be one solution. And for my other solution, I need it to be in the fourth quadrant. So 360 minus 14.4775 ... degrees. So those are going to be my two solutions. So answer plus 180 on my calculator gives me 194.4775 ... degrees. And 360 minus the acute angle gives me 345.5224878 degrees. So remember, these are the values for t. So to find theta, you need to divide by 2, right? Because t is 2 theta. And so these are going to be your two solutions. If you divide by 2, you get 97.2 degrees. And if you divide the second expression by 2, you get 172.8 degrees. All right, so those are going to be your two solutions. All right. All right, so we are going to do question 4. So 4a says sine squared x plus 3 sine of x cosine of x plus 2 cosine squared x is equal to 0. And we are solving this for x is between 0 and 2 pi. All right, so I want to divide through. So dividing LHS by cosine squared x. And the reason I'm doing this is going to make sense. So I will get sine squared x over cos squared x plus 3 sine x cos x divided by cos squared x plus 2 equals to 0, right? So if I divide my last term by cos squared x, I get 2. All right, so this term is going to simplify to tan squared x. This term, 1 cosine x and cosine x will cancel out, and you get 3 tan x plus 2 is equal to 0. However, we have one assumption, and the assumption is that cosine squared x cannot be equal to 0. Why? Because we divided the left-hand side, so it's in the denominator. It cannot be 0. This means cosine x cannot be equal to 0, and that means cosine, so that means x cannot be equal to pi by 2 or 3 pi by 2. Because at 90 and 270, cosine of x is 0, right? So we have these two angles are not possible in this case. All right. Now this, I can write this as, if you use the sum and product method, you can split the middle term as follows. So you can split it as tan x plus 2 tan x plus 2 is equal to 0. Because the sum is 3, the product is 2, so your two numbers are going to be 2 and 1, right? So you will get this. And if you factorize out tan x, you will get tan x plus 1 plus 2 times tan x plus 1 equals to 0. Alright, and this can be split as tan x plus 1 times tan x plus 2 equals to 0. And now we can easily solve this. So first of all, let's let tan x plus 1 equals to 0. And that just means tan x is equal to negative 1. Now, for which angles is tan of x negative 1? Well, we know that if x is equal to pi over 4, which is 45 degrees, tan of pi over 4 is equal to 1. And remember, this is an acute angle. So if we know the acute angle, we can figure out which angle gives the negative of that value by just pushing this angle into the right quadrants, right? Alright, so using that piece of information, so we know that tan pi by 4 is equal to 1. Alright, so one possible value of x is that tan in the second quadrant is negative, right? So we can do pi minus pi by 4, right? 180 minus an acute angle pushes that angle into the second quadrant, and in the second quadrant, tan is negative. And again, tan is negative in the fourth quadrant. So I can do 2 pi minus pi by 4. And this pushes my angle into the fourth quadrant. Alright, so your two answers are going to be 3 pi by 4, and we have 7 pi by 4. Alright, so you have 3 pi by 4 and 7 pi by 4. So these are two possible answers. Alright, so now we also need to solve for this part. Tan x plus 2 is equal to 0, and that means tan x is equal to negative 2. Alright, so let's find the acute angle by taking tan inverse of 2. So we'll ignore the negative sign here for a while. And when we do tan inverse of 2, and remember, we're working with radians. So we set our calculator into radian modes. Tan inverse of 2 gives me 1.107 radians. Alright, or 1.11 radians to 3 significant figures. So that is the acute angle. However, so let's just use the full value, 148,718 radians. And now this is the acute angle. I need to push this acute angle into the, when is tan negative? We need tan to be negative 2. So when is tan negative? Well, tan is negative in the second quadrant. So I push my angle into the second quadrant. And tan is negative in the fourth quadrant. So I push my angle into the fourth quadrant. And when I do so, I get pi minus this acute angle gives me 2.03 radians, and then I get 5.18 radians. So these are going to be your solutions. So your four solutions are 2.03 radians, 3 pi by 4, 5.18 radians, and 7 pi by 4. Alright, so that is the solution to 4a. Let's do 4b. 4b says I have 6 secant cubed theta minus 5 secant squared theta minus 8 secant theta plus 3 is equal to 0, and we are solving within this restriction. And we are working with degrees, so you can already go ahead and set your calculator to degree mode. Alright, so now this looks a bit complicated. So let me set secant theta is equal to u. So I have 6u cubed minus 5u squared minus 8u plus 3. Now this is not a quadratic equation, it's a trinomial, right? So this is a degree 3. I think a trinomial is the formal term. Let me just Google it up very quickly. Sorry, so it's not a trinomial, it's a cubic equations. So a degree 2 equation is quadratic, a degree 3 equation, which is this, is a cubic equation. All right, and we haven't learned how to solve cubic equations before, but let me show you one way to solve these equations. So we are gonna try to factorize this. And as we try to factorize this, what we're gonna do is we're gonna substitute values in. So we're gonna try to substitute in integers. So let's substitute 0 for u. These three terms become 0, and then I get 3 equal to 0. So 0 does not work. Let's substitute positive 1. So if I substitute positive 1 for u, I get 6 minus 5 minus 8 plus 3. So that gives me negative 8, right? Which is not equal to 0. Sorry. 6 minus 5 is 1, minus 8 is negative 7 plus 3. I get negative 4, which is not equal to 0. So substituting 0 did not work, and substituting 1 did not work. So let's try negative 1. So I substitute negative 1 here, I get negative 6. I substitute negative 1 here, I still get minus 5, right? So I'm just doing 6 times negative 1 cubed minus 5 times negative 1 squared minus 8 times negative 1 plus 3. All right, so when I do this, I get negative 6 minus 5 plus 8 plus 3. All right, so minus 6 minus 5 is negative 11 plus 8 plus 3. This gives me minus 3 plus 3 gives me 0, which is what I have on my right-hand side. So substituting in negative 1 works. So now that I know that, subbing in negative 1 works, here's what it means. If putting negative 1 into this function gives me 0, then u plus 1 must be a factor. So what I'm saying is that this expression can be written as u plus 1 times something equals to 0. Why? Because if negative 1, putting in negative 1 gives me 0, then putting in negative 1 here gives me 0. So we're looking for this other polynomial term. So how do we find that? Well, we take this whole equation here and we divide it by this factor that we just found, u plus 1. So now how do we divide this? Well, when we try to divide two polynomials, and because it's not covered in your syllabus, you can find YouTube videos on this, but here's what you want to do. You want your first term, you want this to be in descending order, and you want all powers to be covered. So you have u to the power 3, 2, u to the power 1, and u to the power 0. All right. So now you want your first term to match, right? You want your first term to match. So my first term is 6u cubed. So if I multiply, if you think about it, u times 6u squared will give me 6u cubed. So that means that this term is correct. All right. And now I have to multiply 6u squared with my other term as well, with this term. So plus 6u squared. All right. So I think what I need to multiply with to get my first term, so I need to multiply with 6u squared with u to get the first term, and then I shouldn't forget to multiply this with 1 as well. All right. So now I do a simple subtraction. 6u cubed minus 6u cubed gives me 0, minus 5u squared minus 6u squared is minus 11u squared. And then I drop everything down, minus 8u plus 3. All right, so what do I need to multiply u with to get minus 11u squared? Well, I need to multiply it with minus 11u. And that gives me minus 11u squared minus 11u, right? And now I do a subtraction again. So these two terms cancel out, if you think about it, and I will get 2u over here. Sorry, I will get 3u over here plus 3. I bring this down. And finally, if I multiply with 3, I get 3u, right? 3 times u is 3u times 1 is this. And if I subtract, I get 0. So that means that this polynomial here can be factorized as u plus 1 and then this expression. So 6u squared plus 11u, sorry, minus 11u plus 3. And I'm so sorry if you can hear the dogs outside. They're going crazy tonight for some reason. All right. So now that we have this piece of information, let's see if we can factorize this further. This is a quadratic equation, and we know how to factorize these ones. All right. So what is the sum? The sum is negative 11. What is the product? 6 times 3, that is 18. So let's think of two numbers. Well, 9 times 2 is 18, negative 9 times negative 2 is positive 18, and then the sum is negative 11. So we can write our middle term as 6u squared minus 2u minus 9u plus 3. Alright, and now I can write this as u plus 1 times this one. I can write it as, from the first two terms, I can factor out the 2u, and I can write it as 3u minus 1. And from my second term, I can factor out a negative 3, and I can write it as 3u minus 1. Alright, and now I can write my cubic equation as follows. Right? If you factor everything out here, you get this expression. Alright, so now that we have this expression, we just need to set everything individually to 0. So let's say u plus 1 is equal to 0. That means u is equal to negative 1. And what was u? Remember, u was secant theta. So secant theta is equal to negative 1. That means 1 over cos theta is equal to negative 1. That means cos theta, if you exchange, is equal to negative 1. And theta, so we are solving between 0 and 180 degrees. So the only value that gives me negative 1 within that is 180 degrees itself. Cos 180 is equal to negative 1. Alright, so that's one solution. Let's look at this one. 3u minus 1 is equal to 0. 3u is equal to 1. U is equal to 1 over 3. But u is just secant theta, right? So secant theta is 1 over 3. 1 over cos theta is equal to 1 over 3. And 3, if you simplify, is going to be cos theta. But this is not possible, right? Because cos theta cannot be more than positive 1. So we ignore that. Finally, we use this. 2u minus 3 is equal to 0. 2u is equal to 3. U is equal to 3 over 2. And u is just secant theta. So cos theta, if you solve for cos theta, is going to be 2 over 3. So now let's just find. And remember, between this angle, cosine is a 1-to-1 function, right? If you remember, we restricted cosine to this domain. So we can directly get the angle by taking cosine inverse. We don't have to adjust for quadrants within that range because it's 1-to-1. So we're only going to have one answer when we take the inverse. And I want to be in degrees mode. So cosine inverse 2 over 3 is 48.2 degrees. So we are done. So our two solutions are 180 degrees and 48.2 degrees. So my laptop is not working. Okay, it's working now. So yeah, 48.2 and 180 degrees. Alright, so we are done with part B. Now finally, let's go and do part C. Sorry. So we have 2 cot cube x plus 3 cosecant squared x minus 8 cot x is equal to 0. And again, it's the same domain. Alright, so now I know that there is a relationship between cot and cosecant x, and that is as follows. Cot squared x plus 1 is equal to cosecant squared x. So I'm going to substitute this expression here. And that's because I just want to work with one variable, which in this case is cot x. So cot squared x plus 1 minus 8 cot x. Alright, so I get that expression, right? And if you simplify, you get 2 cot cubed x plus 3 cot squared x minus 8 cot x plus 3 equals to 0. Once you simplify everything. Alright, and it's the same thing now. So I'll just let u to be cot x. And I get 2u cubed plus 3u squared minus 8u plus 3 is equal to 0. Now let's substitute some values in to find a factor. Alright. Let me substitute 1 in. If I substitute 1, I get 2 plus 3 minus 8 plus 3. And I think this works, right? This gives me 5 minus 8 plus 3. 5 minus 8 is negative 3 plus 3 is equal to 0. So 1 works. Substituting 1 works. Alright, so that means if substituting in 1 works, then that means my factor is just u minus 1. Why? Because if putting 1 here gives me 0, then I should be getting a 0 when I put 1 into the factor as well. And I need to find the other part. And to find the other part, we just do the same thing. We write the cubic equation in descending powers. So in case there was no 3u squared, I would have to write 0u squared. I want all the powers to be there. Plus 3. And we write u minus 1. Alright, so now I need to multiply by 2u squared to get the first term, right? U times 2u squared gives me 2u cubed, and I have to multiply with negative 1 as well. So I get this expression. And now I can subtract. These cancels out, and I get 5u squared minus 8u plus 3. Alright, so now I need to multiply by positive 5u with u to get 5u squared. And then I need to multiply 5u with negative 1, I get minus 5u. And now I can subtract, and I get minus 3u, and then this positive 3 drops down. Alright, and now finally, if I multiply u with negative 3, I get negative 3u, and if I multiply 3 with negative 1, I get positive 3. With negative 1, right? So I get this expression. If I subtract, I get 0. So now I know my other term is just 2u squared plus 5u minus 3. Now let's see if I can factorize my second term. Well, the product is negative 6. The sum is positive 5. So I can do 6 and negative 1. Alright, u minus 1. Then I have 2u squared plus 6u minus 3 is equal to 0. U minus 1. I can factor out 2u. So I get u plus 3 minus 1u plus 3 equals to 0. And finally, if you factorize everything out, you are going to get u minus 1, u plus 3, 2u minus 1 is equal to 0. Alright, so let's solve u minus 1. The first term is equal to 0. And that means u is 1. And u, remember, is just cot x. And cot x is just 1 over tan x. And you are just solving for tan x is equal to 1 within this domain. And remember, only x is equal to 45 degrees is going to satisfy that. Why? Because in the first quadrant, tan 45 is equal to 1. In the second quadrant, tan is negative. And we only go from the first quadrant to the second quadrant. So we don't need to worry. Alright, so u plus 3 is equal to 0. That means that u is equal to negative 3. That means that cot x, negative 3. And if you solve for tan x, you're going to get negative 1 over 3. Alright, so now how do we find x? We just use our acute angle. And how do we get our acute angle? We take tan inverse of the positive value. And that gives me, and we are working with degrees, so tan inverse of 1 over 3 is just 18.4349 something. And now I need it to be negative. Tan of x is negative. So I need to push this acute angle. In the first quadrant, it's positive, so I need to push it into the second quadrant. And to do so, I just need to subtract this acute angle from 180. And I get 161.6 degrees. Alright, so that is my second angle. And for my third angle, I work with this one. 2u minus 1 is equal to 0. So 2u is equal to 1. U is equal to 1 over 2. So you get cot x is equal to 1 over 2. And tan x is just going to be 2. And to solve for x, you just get your first quadrant solution by taking tan inverse of 2. So you get 63.4 degrees. And yep, that is it. Those are your three solutions. 45 degrees, 161.6 degrees, and 63.4 degrees. And we are done with this topic and with this chapter. Alright, so see you for the videos for the next chapter.